So coming back to the theme of today's session, we saw in Galileo the poignant example of someone that believed that the aim of science was not just to save the appearances, but to provide us with the true story about the world. Now, this view is known in the philosophy of science literature as scientific realism. Scientific realism says that the aim of science is to provide us with theories which, literally construed, we believe to be true. There are two different aspects in this definition. The first is a semantic aspect. It has to do with the language of science, the language in which our theories are formulated. And it basically says that we should take the language of science at face value. So if we have a theory, say Copernican astronomy, that talks about planets, we should understand the term planet as referring, as picking out objects in the external world. Same for any other theoretical terms. If we have a theory about electron, we should understand the term electron as referring, as picking out electrons in the world. Then there is a separate aspect, which is an epistemic aspect. And that says that whenever we accept a scientific theory, we believe that the theory is true, or at least approximately true. In other words, whatever the theory says about those objects, be they planets or electrons, correspond to facts in the external world. Now, appealing and intuitive as this may sound, as we have just seen with Ptolemy and Simplicius and Osiander, this was not the way in which, for many centuries, science was conceived. So we need a proper philosophical argument for scientific realism, and the argument is known as the no miracles argument. So in the original formulation of Hilary Putnam, the no miracles argument says that scientific realism is the only philosophy that does not make the success of science a miracle. That terms refer, that theories are approximately true, that the same term can refer to the same objects even if it occurs in different scientific theories. These statements are the only explanation of the incredible success of our science. So a natural account of how science grows and unfolds, say, how the way in which Newtonian mechanics replaced Aristotelian physics, or Copernican astronomy replaced Ptolemaic astronomy, or Einstein relativity theory replaced Newtonian mechanics, is that a partially correct, partially incorrect account of a given object is replaced by a better account of the same object. But the no miracle argument says, if those objects don't exist, if our theories were not really true, or at least approximately true, of the same objects, then it would be just a miracle that we have a theory like Newtonian mechanics that talks about gravitational attraction and is so successful in predicting phenomena. If curved space-time didn't exist, then it would be just a miracle that a theory like Einstein relativity proves so successful, again, in predicting phenomena like the perihelion of Mercury, and so on. In other words, one must be a scientific realist in order to explain the incredible success of our science across centuries.